Henry Cavendish was very wealthy, and he did a lot of things. Apparently, I've listened to some very respected physics teachers praise his work, and I studied some of his work. But mostly, what I was interested in was how he determined this gravitational constant. Cavendish apparently had a lot of property, a lot of money, and he set up an experiment. Cavendish built this box, this wooden box on his property. Looks something like this. Okay? And in this box, there was a pulley with a rope leading outside the box, something like that, a little handle on it. And what hung from it was this thing called a torsion rod. Looks something like this. And on the ends of the rod were these large lead balls. And on the inside were these smaller lead balls. Something like this. Pulley right here. And he used lead because it's very massive, it's very dense. And he, apparently, according to the history, he knew that he had to get away from the box because his gravity, his mass, would affect the experiment. Assuming that this is correct, that the force of gravity is, there's a force of gravity between any two masses, not just the Earth and us. All masses have a force of gravity on each other, or create a force of gravity on all other masses based on this equation and the proportion that Newton came up with. So he somehow set up some telescopes that went back to his house. Keep his house off the board, just assume his house is down here somewhere. So he could observe this experiment, and somehow he calculated big G from this. Okay. Well, when I started researching this, I said, okay, well, let's see some examples of a modern day torsion rod experiment that somebody's built that shows how this works.
There's another set of lead balls inside there. This experiment really is very difficult to get to work, and a technician has sawed it apart because he got so frustrated. However, you could measure the period of oscillation of this, and from that get all the properties of the wire, the torsional constant. And that enabled him to measure big G, the gravitational constant, to an accuracy of 1%. And nobody improved on that for 100 years. And nobody improved on that for 100 years.
Well, I couldn't really find one. I actually had a lot of trouble finding one. Actually, one of the physics professors that was praising him had a little model that he held up and was joking that his TA couldn't get it to work and got frustrated with it and gave up. And I'm thinking to myself, over 200 years later, we don't have models of this, or repeats of this experiment all over the place that determine big G? It didn't make much sense to me.